Thank you, Matthew. That was a very generous introduction. It's a great pleasure to be here. It's an honor to meet many of you and come to this very, very nice city in Central Europe, a city that I've never been to. So it's a double pleasure to be here. And I'm going to talk today about my research, which looks at environmental issues and the connections that it has with climate change. So before the talk, we got a very nice tour of the Basilica and the library, and we got to know about the rich history of the place. So in some sense, it's like a wonderful place to talk about things in the future, things about, relating to climate change and other such issues. So it's a privilege to be here. Thank you. Yeah. So when you think about climate change and when you think about greenhouse gas emissions, a significant proportion of these emissions can be attributed to the burning of fossil fuels, we know that, and this is mainly for electricity generation. So if you look at, for example, data on emissions by sector, and this is data for the whole world, what you can see is electricity generation is one of the very important contributors to climate change, right? So there are many other sectors which also contribute, for example, transport and manufacturing and construction and other such sectors, but this is obviously a very big part of this problem, right? On the flip side, the problem is that electricity is also considered an essential service. So it is needed to keep increasing productivity in the world, right? And it's also needed to make sure that people have, secure, so you need to have a secure and you need to have some kind of cost-effective way of generating electricity. So policymakers have to balance these different objectives. How do you try and make sure that there is enough electricity for the world, for people who are vulnerable, for people who depend on it, but also do it in a way that is cost effective and that is not harming the environment. So that's one of the big issues that we have facing in our world currently, right? And one of the options that has been suggested is to have a market-based solution. And this has been suggested for many different kinds of environmental problems. And one of the reasons why this is seen to be useful is because it is a cost-effective solution. So basically, you can achieve your environmental goals at the least possible cost to society. And the reason why these markets can work is because you can have a price mechanism in the market, and these can help us understand where is the demand and supply coming from, and try and match it in such a way that you get to your environmental objective at the most cost effective, via the most cost effective route. Of course, how effective environmental markets are going to depend on what are the kind of market rules, what are the kind of pricing mechanisms that are introduced in these markets, and also how do individuals respond to them. So what is the behavioral response to these kinds of price mechanisms or marketing or market rules, right? So what I'm going to do today is to share findings from two projects which are designed using features from real world markets. So these are going to be carbon markets and also markets where one is thinking about the best way to price electricity. Okay, so those are the two aspects that I'm going to focus on. So let me just put up a roadmap just to set our agenda for the next hour. So I'm going to start with just to give you a bit of a sense about my broad research agenda, though I think Matthew has done a very good job of doing that, so I may not need to add much to that. But the basic idea would be to just position what I'm talking about today within my broad research interests, so that if there are other topics that spark your interest, you can feel free to come and talk to me after this. Okay. I'm going to spend a little bit of time talking about the research methods that I'm going to be using today, and which I think many of you are familiar with already. So this is going to be the experimental approach, which is used quite often in economics to try and understand different kinds of policies and to test different policies. Then I'll talk very briefly about carbon market, and the market that I'm going to focus on is a regional greenhouse gas initiative, and I'm going to look at specific design features of this market and what does it mean for the outcomes in this market. And the second project is perhaps where I'll try and spend a little more time, and I'll be talking about an electricity pricing mechanism here. And this will be the real-time pricing mechanism, which is getting a lot of attention. It's a dynamic pricing kind of a mechanism where the prices change often, frequently. It's like sort of like, you know, when you get an Uber, you may pay different prices depending on the time of the day, depending on congestion and other such things. So this is being also, you know, used in the electricity scenario, that the electricity prices are going to change depending on what is happening with demand and supply at that particular time. And this is very attractive for economists, obviously, for the reasons that you can assume, that you can think about, but also this leads to a lot of concern for consumers. And I'm going to basically be focusing on that. So the project will be looking at what is the risk to consumers and what should policymakers be doing about this risk that consumers face. And then I'll just end with some hopefully general insights, and maybe there'll be some discussion and questions that you will have. Okay, so as was just mentioned, so mainly I'm interested in trying to understand different kinds of institutions. Sometimes these are environmental institutions, sometimes these are institutions in other more general social arena. And hopefully in that process, I hope I can also try and help improve institutions. And the approach that I've used mainly has been experimental approach, and in, you know, so I use lab experiments, and basically different kinds of experiments, lab in the field experiments. Also, when there is an opportunity, I've also tried to exploit the variation caused by policies, so which is like a natural experiment. Okay? And my focus is basically on, you know, trying to understand what kind of incentives work to make people become more cooperative or comply with regulations, what kind of, and how does it interact with preferences. And my current research revolves around 3 themes. So the first one is the one that I'm going to be talking about today. So that focuses on environmental and social dilemmas. The second one deals with pro-social and anti-social actions. So pro-social actions could be thought of as charitable giving and, you know, other aspects related to altruism. Anti-social actions can be thought of as dishonesty or corruption, which has an impact on social outcomes. The third topic is on gender and leadership and the role played by norms, gender norms and other kinds of social norms, and the role played by beliefs. And this I have an opportunity to talk about it later in the week at the Young Economists meeting. I think my talk is on Friday, so just a little flag up there to alert you to that talk if there is an interest. Okay. So as I said, I'm going to be showing you results from economic experiments. And economic experiments can be quite useful, especially when you're trying to identify and define specific forms of behavior. And also, it can help you compare what you're finding empirically with theoretical concepts. So experiments can allow us to make changes in one variable while keeping all the other variables constant. So that's very useful, because then that helps us understand whether there's a causal effect of that particular variable. Is that particular variable causing the results that you're seeing? It allows for a robust baseline or a counterfactual. And this is not always easy when you're using other kinds of empirical approaches, because you might not really have counterfactual for different kinds of observational data, right? You might have to create a counterfactual, which is not really sometimes as appropriate. And also importantly, for the kind of things that I'm going to be talking about today, experiments can be quite useful to test different kinds of institutions. So when you're trying to think of whether a policy is effective, or whether you're trying to think of what kinds of policies should the regulators be thinking about, then experiments are very useful. They're very, in some sense, cheap, because otherwise you have a policy which has been rolled out and you don't quite know whether that's going to be effective or not. right? So experiments can be useful in testing different kinds of policies and trying to improve policy making, and you can also link it back to theory and it can help you understand and maybe improve economic theories, because economic theories might not always coincide exactly with what experimental results show you people are doing, right? So then there is an opportunity to go back to theory and improve the theory in terms of the results that you find in the experiments. So experiments, of course, are a nice complement to other kinds of empirical approaches, like using observational data. But in some cases, as compared to observational data, you can collect better quality data using experiments. And this is because in experiments you can, so for the context that I'm going to be talking about, which is a market context, with the observational data, it's very hard to actually find data on individual bids in auctions, right? So most of this data, that is how much do firms bid or how do individuals bid, might be private information. So you may not be able to find this data when you're using just survey data or observational data. And also, similar to that theme, in terms of valuations of allowances or permits, that's also going to be private information. So how much do firms value a particular permit, or how much do individuals value a permit for pollution? All of that is not information that you're going to get when you use other kinds of data. But with experiments, as a researcher, when you're designing the experiment, you can actually find ways to to have this data, because the values in this kind of an experiment would be induced value. So you are providing the value to the participants who can then use it to trade in the market. Okay, so researchers have a lot more control when they're using experiments, and that can be quite useful. The other aspect which is also very important is that behavioral influences can be easier to examine and vary using experiments. So if you want to, if you think that there are multiple reasons why you're finding the results that you are finding, then you can design new treatments or new scenarios where you can shut down some of the channels, right? So you can then identify what is the correct motivation, or what is the motivation for subjects to be doing, or participants to be doing what they're doing in the experiment, right? So there are many ways to try and understand the mechanisms behind your main results, and experiments are useful to do this, okay? So there have been a lot of papers which use experimental methods to try and understand environmental problems, so much so that now we have lots of survey papers which have been written on this topic. So if any of you are interested in this area, I just have a list of survey papers. It's not a comprehensive list, but these are just example papers that are available and which you may be interested in looking at. So there are now surveys on lab experiments which have been used in the environmental area. There are also field experiments which have been used in the environmental area. And also recently there has been work which looks at the choice of institutions. So these are exogenous institutions versus endogenous institutions, and institutions which help you cooperate or improve cooperation in social dilemmas and environmental dilemmas. So for example, like in common pool resource problems or public good problems, how do you improve cooperation? So there's a nice survey article which looks at that. So yeah, so basically this is an approach which is useful and which you may want to incorporate in your decision-making tool or your approach towards research. So and that brings me to the first project that I want to share with you today, and this is titled Mind Your P's and Q's, and it's about variable allowance supply in the US Regional Greenhouse Gas Initiative Program. And this is a published paper, so I'm not going to talk about the details of this experiment. I'm just going to talk about the intuition and maybe present one main result from the paper. Okay. This is joint work with Lana Friesen and Ian McKenzie, who are both at the University of Queensland, and with Payman Kurz, who is at RMIT, which is in Melbourne. So I mentioned how market-based instruments are quite popular in the environmental area, and this is because of the fact that they're seen to be very cost-effective. So one of the market-based instruments which has been used a lot in the environmental area is a cap and trade scheme. So cap and trade scheme is one where the regulators decide on a threshold or a cap, and then they decide how many permits are going to be allowed, and then people can trade these permits with each other. So it's basically defining a cap and then allowing people to trade between each other. And auctions are very often used to allocate these pollution permits which are created. So when the regulators give out these pollution permits, they have to find a way to give it out. So who gets these pollution permits, right? And auctions are often used to allocate these permits, because again, auctions are useful to get people to reveal their true preferences for these commodities. And variable allowance supply is a very common feature in pollution permit auctions. It is used a lot. It's been used, I think, in the European emission trading program. It's used in California's trading program. It is also used in REGI, which is where I'm going to be basing this experiment on. And it's basically, what it means is that the supply can be varied, as the name suggests, right? So the initial supply can be varied, and the way to do that is to have an allowance reserve, which is basically a separate quantity of permit or allowances that can be used to adjust the initial supply up or down. Okay? So you can increase the supply when the initial price is too high. So if the regulator thinks that the initial price is too high, then they can put in some more permits in the market, some more allowances in the market, and that will then obviously reduce the price, right? Or they can decrease the supply when the initial price is too low. So the reason why they might be worried about too high prices is because of the fact that it might be very expensive for firms to reduce their emissions, right? So they are worried about containing the costs in some sense for the firms. And the reason why they might be worried about the initial price being too low is because of the fact that then it does not help people to invest, so then there is no incentive for people to invest in technology which will reduce emissions, right? So you want prices to give the right signal in some sense. So that's why when the price is too low, then it's a good idea to decrease supply. Okay? And how do you know who decides what is a low price and what is a high price? It's decided by the regulator. So this is going to be predetermined by the regulator, and these are therefore called trigger prices. So if the price is higher than the trigger price, then you add more supply to the market. If the price is lower than the trigger price, then you take away supply from the market. Okay. So what we are going to do in this paper is we investigate the new institutional design of the REGI market, which basically uses dual allowance reserves, which is the Qs, and trigger prices, which are the Ps. Okay, so the paper is basically about these Qs and Ps, which are the quantities and prices, and how are the regulators going to decide on the initial Q, initial supply, and then how are they going to decide which is the point at which the price becomes too high or too low. Okay, so it's a very simple kind of a story, and we are trying to understand when regulators predetermine the P's and Q's, what is the impact on the market? How do they change market outcomes when they predetermine these things? Okay, so what is REGI? So it's basically an initiative which started in 2008, and it regulates carbon dioxide from the power sector in the US, and this has 11 northeastern US states. I think I have a map here. Yeah, so these are the states there on that side. There are 11 of them there. And it uses a declining regional cap. So the threshold keeps declining every year, which basically means that the emissions are decreased every year, right? And since 2008, they have been decreased by more than 50%. So this is just the blown up image of this map here. So you can see that there are these 11 states, and you can see all of these states here. It includes Connecticut, Delaware, Maine, Maryland, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island, Vermont, and Virginia. Okay? Okay, so that's what REGI is. Now, What is the system? Let me just give you a little more details about this particular market. What they do is they conduct auction 4 times a year, and they use a particular auction mechanism. It's a multi-unit uniform price auction, and each allowance accounts for 1 ton of carbon dioxide. And it generates a lot of money, so it generates about US dollars 100 to 150 million. And the money is basically used, it's invested in energy and consumer programs in these particular states. So basically it's invested in green programs. Okay, so all this money is used for either renewables or for other kinds of things within these states. So the revenue is an important aspect of this market. And what they did was in 2014, they started a policy of having a cost containment reserve. And this is so that when the price goes up too much, too high, then firms might be at a disadvantage, because then the cost of reducing these emissions, or the abatement cost as it's called, can be very high for firms. So to not disadvantage them, they started a cost containment reserve. And then recently, they also implemented an emissions containment reserve. And this is basically a reserve which is to try and make sure that the emissions are not too much. That is, you want to contain the emissions and make sure that the program reaches its environmental objective. Okay? Right, so this is what the supply curve looks like in the REGI market. So let's say that, so this is I think data from 2021. So the initial supply in the market, supply of allowances in the market was about 15 million, okay? And the trigger price for the release of the cost containment reserve was seen to be $13 per ton. So that's this trigger price here. So if the price goes higher than this, so let's assume that there are some demand curves here. So this is a supply curve. Let's assume that there are some demand curves here. And if the demand is such that the price goes above this $13, then this amount of allowance is going to be released in the market. Okay, so there's going to be this additional supply that comes into the market. So that's this bit here, right? And for the ECR, that's the emissions containment reserve. So the trigger price was $6 per ton. So, and what that means is that this additional supply is going to be taken away. This supply is going to be taken away from the market so that the prices go up in the market. Okay, so this is data from 2021, and this is how they were managing it. And in our experiment, what we are going to do is we are going to try and have a supply curve which looks like this, and we're going to try and mirror the important features of this market in our experiment. Okay. So here I'm going to be presenting you some data on lab experiments, results from lab experiments. And we are going to investigate how this new institutional design, which has both an upper and a lower allowance reserve. So this is the CCR and the ECR that I just showed you, and the associated trigger prices. How is that going to impact regulatory outcomes? In the paper, we talk about price, quantity, equilibrium price, equilibrium quantity, and revenue and efficiency. Here, I'll just show you one result on the prices, the clearing prices, because I think that's the main result in the paper, the interesting result in my view in the paper. Okay, so this is what we do. So we have some theory to understand the REGI market. So this is the framework that we use, and this is exactly what I showed you before. It's just that now I'm using more abstract notation here. So here we have a maximum number of allowances, which is Q bar, and this is the initial supply that the regulator puts in the market. And if you need to add to it, then this is the amount that you would add. If you need to subtract, then this is how it is, right? And these are the trigger prices. Okay, so this is exactly what we saw before. And now let's introduce some demand curves to this figure. So there are 3 demand curves here. So that's what we have superimposed on the supply curve that we saw before. If the allowance demand is as expected, so that is this one here, let's say that the demand curve looks like this, then the regulator continues to supply Q2 in the market. But if the demand is sufficiently high, so let's say that the demand curve is this one here, DHP, then the initial price is going to end up being above the trigger price, right? And therefore, the supply is going to increase. And how much will supply increase? Supply will increase to this point here. Similarly, now if the demand is lower than expected, so that is, let's say the demand curve looks like this, then the initial allowance price is going to be lower than the trigger price, that's this one here, and therefore allowances will need to be withdrawn from supply. So that is, we're going to take this away now, okay? So this gives you a bit of an intuition of what the trigger prices are going to do and how the allowances, the reserves are going to kick in when the trigger price goes above or below a certain point, right? So it's simple demand and supply kind of concept, yes. So let me just show you what we did with the design. How did we design this to understand this particular regulatory feature? I think I've already mentioned some of this. So this is how we have a variable supply with two trigger prices, and you have an ECR and a CCR. But let me just show you some little bit of detail on the actual experiment. So we have a market where we have 4 bidders. So these are 4 firms who are interacting in the market, and they interact for in 25 rounds. Basically, they're interacting 25 times. Okay, and the way the price mechanism works is that we have a sealed bid multi-unit uniform price auction, and in very simple terms what that means is that the price is going to be equal to the highest rejected bid. So the clearing price in the market is going to be determined by the highest rejected bid. Okay? Each bidder will have 2 units and they have the same value for 2 units. So their preferences are such that they value the 2 units equally, and these values, where do they come from? They are basically created by the experimenter. So these are induced values in the experiment, but they are random in the sense that they come from this distribution 0 to 10, and in every period, in every round, they're going to get different values. So their demand curves are going to keep changing depending on what values they get, because when they're told that they value this particular unit for, let's say, $5, then they want to bid a certain amount which then they can still get profits on, right? So if they bid $10 and they're going to make then they're going to lose money, right? And we allow them to do that. They can lose money, right? But if they bid for $2 and they are accepted in the market, then they will make a profit, because it's their value was $5. So 5 minus 2 would be a profit for them. Okay, so that is how the profits are calculated, and these are all incentivized. That is, whatever money they make in the experiment, they get to keep. So the profit is basically the value minus the clearing price that they have to pay. Okay, and there are 4 bidders, and each of them has 2 units. So that means there would be a total demand for 8 units, but only 6 units are available in the market, which is exactly how it works in real life, that not everybody gets to buy at the price that they want, right? Okay, so let's now see what we did. We had 5 treatments or 5 scenarios that we designed. So the first one in red is a baseline or a control treatment where Q2 is the initial supply that they start with, and the initial supply then can be, you can add 2 units to it, which is a CCR, and there are also 2 units in the ECR. So this is symmetric. So both the CCR and the ECR is of equal quantity. And the trigger prices are 6.66 and 3.33, and this basically divides up the value range quite nicely. Okay. In the next treatment, so that's this one and this one here. What we do is we keep all of this constant. So this is what I was trying to say before, that in experiments, you can keep some variables constant and just change one variable at a time to try and understand the impact of that change. So here in low P2 treatment, we change this price here. That's this trigger price. And in the low P1 treatment, everything else is constant, but we change this P1 trigger price here. Okay? And then we have the last two treatment where you can see those are now in blue, and what you can see is as compared to the control, now in the large Q2, as the name suggests, the initial quantity that is supplied is larger than the control, and in the other one it is smaller than the control. Okay? And also what it means is now the symmetry between CCR and ECR goes away, but the prices are exactly the same as what it was in the control. So these two can be compared to the control. Okay? Okay, so what we can do is we can use economic theory to try and understand what the predictions should be, right? So given the parameters that we have chosen in the experiment, we can choose economic theory to understand in each of these treatments what is the distribution of clearing prices predicted to be. And that's what this graph shows. In each of the 5 treatments, in the control, in the large Q2, low P2, small Q2 and low P1 treatments, this is what the predicted clearing prices should be, given that this is a multi-unit auction, etc. And you can, and maybe it's not that clear to you, but let me tell you that these the black ones here are the trigger prices. This is what is determined, in our case by the experimenter, but in the real regime market it is determined by the regulator, right? So these are the trigger prices. And you can see that the predicted prices are clustering around the trigger prices along these black lines. Okay, in each of the treatment you see this bimodal distribution of the predictions. And now we are going to look at the data from the experiment for each of these treatments to see if this pattern appears in the experimental data as well. Okay, so that is the idea of this approach. And now let us see what happens. So this is the result that we get for prices from our experiment. So when we run all these different treatments, what we find is that in all treatments, the distribution of clearing prices is bimodal. Actually, you won't see any difference between this graph and the one I just showed because these are all clustering around these black lines, which are the trigger prices. So they all align with the relevant trigger prices in the particular treatment, and they're all bimodal in distribution. So there is of course some data which is in the middle, as you can see in each of these treatments, but the clustering is at the trigger prices. Okay, so what it's showing us is that these trigger prices matter. These are focal points for people, and it seems as if the market is converging towards those trigger prices, right? So it is not that the market is using the price signal as it should. Instead, it is using the trigger prices as the signal. So as I mentioned, I'm just going to mainly focus on the price result, and I'm not going to talk about some of the other results that we have in the paper. But in general, what we find is that the choice of trigger prices can be very important. And the clearing price increases in both the trigger prices. We also find some results in terms of revenue. So when you have a lower P1, lower trigger price for P1, then this decreases revenue but increases efficiency. So decreases revenue is actually quite important in this market because, as I mentioned before, the money that is collected from the auction, that is the revenue, that goes towards these green projects. So if you have less revenue, then that's going to have an impact on how much funding these projects are going to receive. So that's obviously an important aspect. I won't talk much about the initial supply. We don't find that affecting revenue or efficiency much, so there's not much going on there. We also talk a little bit about individual bidding behavior. So far I've just been talking about what happens in aggregate, what happens in the whole market. But in all of these situations in the real market and in the experiment, the individual behavior is also very interesting to look at. Is it consistent with what you expect it to be? And also whether people are bidding truthfully, so that is if they receive a particular value in that period, are they bidding according to that value, or are they just making up some other number and trying to make money out of the market? So those are all interesting aspects to look at. And what we find is when we look at the individual behavior, we find that the focal point institutional effects are exaggerated by the bidding behavior. And participants seem to mention the trigger prices as an important factor in their decision to bid. Okay, so the bidding behavior is definitely something, the trigger prices are definitely something that seem to be important for them. Okay. In the paper, we talk a bit about bid shading, and I don't know how much interest you have in that, but in many of these auctions, what you find is that people they reveal their true value for the first unit, but then they try to decrease the bid for the second unit, and this is called bid shading. And the reason they do this is so that they can try and get a chance to win the bid, so to get actually a unit from the market, but then once they get that, they want to pay a lower amount, okay, so that they make money out of the market. So there are these behavioral aspects that are quite commonly seen in these kinds of markets, and we talk a bit about that in the paper. So if you're interested, that would be something to look out for. In general, I just want to say that we looked at this particular policy that REGI has of a new dual allowance, which is a new policy for a pollution market. So pollution markets have had allowance reserves, but this kind of a dual allowance reserve is a new policy to have in any of these kinds of markets. So that was an interesting aspect for us to look at, and what we find is that the choice of P's and Q's that the regulators make, they have a significant impact on the outcome, this creates a bimodal distribution around the trigger prices, and what we find is outcomes are more sensitive to changes in the prices rather than the quantities. Okay. Now, the reason why we think this is interesting is because the price of carbon, which is a clearing price in this market, the price of carbon can be heavily influenced by the regulator's choice of trigger prices rather than the cost of pollution control, right? So the reason why we organize markets in the environmental area, why people think, researchers and policymakers think that markets are important to organize for environmental issues, is because prices can signal the cost of pollution control, right? But if that is not happening, then that can be a problem. But if that is being influenced by what the regulators are doing in terms of choosing prices, predetermined prices, then that can have efficiency impacts in the long run. So that's something for regulators to think about. Of course, different regulators may have different goals. So maybe the regulators are more interested in containing costs, or they're more interested in containing emissions. So they might be more interested in increasing revenue, right? There are many different objectives of any particular policy. And so depending on the policy that they are interested in pursuing and the objectives behind the policy, one should think about how to design these policies, right? Okay, so now let me turn your attention towards this electricity pricing problem that we talked about initially, and the consumer protection elements of this electricity pricing problem. And this is joint work with Gordon Leslie, who is a colleague of mine and who is an energy expert, and also with Madeleine Preto, who is a student of ours. Okay, so what is a dynamic electricity pricing issue? What is real-time pricing? So real-time pricing is basically a form of dynamic electricity pricing where the marginal price that is paid by the consumer is going to change frequently. And this is according to what is happening in the wholesale market. Okay? And this you can think of in comparison with a flat rate pricing, which is what most of us are familiar with as consumers. So flat rate pricing basically entails that marginal prices remain constant despite the fact that wholesale prices are fluctuating. Okay? So this is a figure which has been taken from a regulator's website. This is a regulator that offers real-time pricing, and the flat line there is the flat rate pricing. Okay, and this one here, the green one here, is the real-time pricing. Okay, so you can see that the prices are below the flat rate pricing at all times except for this little spike here. Okay, so overall there are price savings, I guess, when you have real-time pricing, but you are also at risk of having these price spikes. So why is real-time electricity pricing seen to be an efficient mechanism? One of the reasons is because it can align these private marginal costs with social marginal costs in the electricity market, and there are many researchers who have suggested that this is a good, efficient way to manage electricity markets, to have real-time pricing. So these are dynamic markets, so things can keep changing, and the price then reflects these changes, right? It can also increase demand response. It can improve grid stability, and it can also importantly support the introduction of renewables in the market, or penetration of renewables in the market, right? But despite all of these theoretical reasons or economic reasons why they are good, what is usually seen is that it's not very prevalent, right? And especially in the residential sector, you don't see many regulators offering these kind of plans. In spite of that, in recent years, what we are seeing is that it is being picked up by some regulators. So even though there is a low base, it is now growing quickly. However, there is not much attention on what the regulatory standards should be relating to aspects of consumer protection. So what should consumers know about this pricing? What is their risk preference? So there's not much discussion about what kind of regulation we need to understand RTPUs. So what is the risk associated with RTP plans? Why are we worried about the risk aspect? So why is the risk important? So you may remember a couple of years back, there was a very big storm in the US, especially in Texas and also some states around it. This was in 2021, February 2021, and this was a winter storm called Uri. And some of the power plants also collapsed during this storm. So there was a lot of demand. There was a surge for electricity during that period because it was a very cold winter, unexpectedly cold winter. On top of that, because of those power plants collapsing, what happened was that the supply was also reduced during that time. So there was a huge demand, but there was a very little supply, right? So obviously there was a power crisis, and what you can see here is this is those 5 days in February in 2021, and the prices were here for electricity, and then they went all the way up there, right? So this is 0 and this is 9,000, okay? So there were lots of consumers who before the storm they were paying $50 per megawatt, and then that changed to $9,000 per megawatt, okay? And one of the electricity retailers, Griddy, there was a lawsuit against this retailer because of the fact that customers had these huge bills that they couldn't afford paying, and they asked the state government to try and get their bills excused because there was no way they could pay this huge amount of money. And there was this lawsuit against the retailer was successful, and because of the fact that it was felt that Griddy took advantage of the fact that customers don't know much about this RTPUs and the risks associated with this real-time pricing, and that their advertising was a bit misguided, and there was a bit of fraud going on with their advertising. So because of that, the lawsuit was successful, and then actually I think Griddy went bankrupt. They had to file for bankruptcy, okay? So this is a problem from the customer side. It's also a problem from the retailer side. So if RTP is a good mechanism, then we should have more retailers offering it. But if retailers have this risk of lawsuits and other such problems, then many retailers are not going to offer it, right? So from both the demand and supply side, we need to think a bit more carefully about what these risks are and what policymakers can do about it. Okay, and that's what this project was inspired by. Okay. So yeah, so this is just showing you another figure from that time. So this was definitely quite an unexpected event in some sense, because when you look at prices from 2015 onwards, the prices were quite stable for quite some time, and then there was a big spike. So this doesn't happen that often. You can say that it's a bit of a rare event, but when it happens, it can be a huge impact on everybody concerned. right? And it is expected that these kinds of so-called rare events are now going to happen more and more often. So the frequency of these so-called rare events has, been going up over time. And if I look at prices in Australia, there was a huge spike last year, and I think many parts of Europe also had these huge spikes, right? Thanks to the war in this region and many other reasons, energy prices have been going up and been spiking from time to time, right? So, so this is not something that is rare. It's going to happen more and more often. So the questions that we are asking here is, does information provision regarding the risk relating to RTP plans, does it have an impact on the uptake of these kind of plans, right? So that's the question, the first question. And how does the offer of products with tail risk protection affect consumer demand for RTP relative to the fixed rate pricing electricity products? So we are going to have multiple kinds of RTP products. So one is going to be a standard RTP product, and another one is going to be one which has a hedge introduced, which provides some tail risk protection. And we are also going to see whether consumers improve their understanding of the tail risk involved with RTP products when they are given more information. Okay? The other aspect that we are going to study, so these are going to be in some sense separate treatments, is, can exposure to wholesale electricity prices through RTP products, can that have an impact on the demand for tail risk protection? Okay? And again, whether exposure to these kind of high prices, whether that can have an impact on their comprehension of what the risk associated is with these kinds of products. So we're going to look at information and exposure. Those are the two main aspects. And we're going to design an experiment to understand the role played by both of these aspects, the information aspect and the exposure on product choice. Okay, so yeah, so let me just show you this. So for the information, to try and understand whether information has an impact, we have a control treatment where we give standard information, and a treatment where we have detailed information about the risk. Okay? And the treatments are also going to vary the product offering. So that is, as I mentioned before, we are going to have different kinds of RTP. So we are going to try and tease out whether the choice between this fixed rate and the real-time pricing, is that going to depend on what kind of RTP is being offered, right? So does offering different kinds of RTP change this choice between flat rate versus dynamic pricing? And then we are going to look at exposure. So all the participants are going to interact in multiple rounds, and after the first round they are going to get information about what their bills were and what were the prices that they faced. So they are going to be exposed to the risk. So irrespective of which choice they choose, they always get information about what the prices are going to be in each of these rounds. Okay, so and the prices that participants faced are exogenous. And they are going to be randomly drawn from a common distribution. So because these prices are exogenous, they are not going to be able to change their consumption habits or anything like that. That's how we designed the experiment. So what that means is these prices, because they're just getting, the price realization is exogenous. So that means you can interpret this as a causal variation on, and what is the impact of that causal variation on subsequent choices that they make. Okay? So this is going to be an experiment similar to the previous one, where we are going to calibrate it to real world settings. And this is obviously, as I mentioned before, this is going to be a nice complement to observational studies that you can have in this area. It's also, many of these products, as I mentioned before, they are not common enough, or they're not being used commonly enough that we have enough observational data, right? So we'll have to wait for many more years to have enough data sets to exploit this. But at this point, we don't have enough about it, but still it's growing, and we need to learn about how these products are having an impact on society, right? So that's why we're going to focus on an environment where we have more control. So this is going to be an online experiment which has features of like a lab experiment, but we'll be running it with participants who are not at the university, but with other kinds of more representative participants. Right, so the choices that people are going to make in this experiment are between a fixed rate plan and a dynamic pricing plan. So what are the aspects that are going to be important in this choice? So if we think of the utility that people get from a particular choice, so let's say that the utility they get from a fixed rate pricing plan is UI FRP, and let's say that we normalize that to 0. So then the utility that we get from a dynamic pricing plan, it is composed of two elements. One of them is the perceived savings that they're going to have in terms of price relative to the other plan, the fixed plan. And the other component is the perceived risk that they're going to face when they go for a dynamic plan as compared to the fixed plan. Okay, so there are two components here, the price and the price savings and the risk. And what we're going to be doing is to see how do respondents choose between these two, and how does obtaining more information affect this choice. And also, does experience with the product affect their subsequent choice? That is, do they make different decisions in round 1 versus in the next few rounds? So here we have 4 scenarios. So these are 4 scenarios in which respondents can be in. So they can be in people who are making these choices, they can be in 4 different scenarios. So you have this first one is the product choice, so that is a fixed product choice that they end up choosing in the standard information treatment. And the second one here is the choice in the detailed information treatment. Okay? And each of these cells is the same thing. So the first choice is what they make when they have the standard information. The second choice is what they make when they have detailed information. Right? So as you can see in this first scenario and the fourth scenario, basically there is no change. So in both these cases, they are making the same choice. So you have the fixed rate being chosen with standard information and the fixed rate being chosen with detailed information about the risk. And in this last fourth scenario also, it's the same thing. With both the standard and the detailed information, they're making the choice to go with the dynamic plan or the real-time pricing plan. Right? So the interesting ones are the scenario 2 and 3. And what do you find here? So scenario 2, for example, is one where they're moving. So scenario 2 is where initially with the standard information, people choose the real-time pricing, and then with more information, now they choose the fixed pricing. And this could be because of the fact that the perceived risk is higher. That's why with more information now they find that the risk is higher, they understand the risk better. If that is not so, then it is possible that the perceived price savings are lower when they get more information. Right? And scenario 3 is one where they are moving from fixed to the real time, and that could be because of the fact that the perceived risk is lower when they get more information. They feel that they are facing less risk, or it is possible that the perceived price savings are higher. Okay? So now with our data, we are going to see which of these scenarios are going to work out, what is the mechanism. So is it the price mechanism or the risk mechanism that is going to explain our data. Okay, so this is for standard information versus detailed information. One can do the same exact thing, everything else is the same, it's just that now we have the other treatment, which is within subject treatment. So that is what do they do in the first round versus what do they do once they are exposed, once they get information in the second round. Okay, so that's the same thing that we have here. And the mechanisms would be the same. Okay, so we have data from about 600 participants. These are all people who live in Australia, and they are they are decision makers in their households, that is they make decisions about electricity options and what other kinds of decisions in the household. And as I said, we ran these experiments online, and they have 3 tasks that they perform. So the first one is the electricity plan choice task. So this is our main task, and I'm going to give you a little more details about this task. In addition to that, we also elicit their risk preferences, because that could be important for choices like this. And we also at the end have questions on their risk perception and the perceptions of price savings as well. Okay, so let me just show you the design for the plan choice. I won't go into too much detail here. I think I've mentioned pretty much a lot of this. So we have the standard information and we have a detailed information. And as I said, we are going to have a flat rate plan, and we also have 2 real-time pricing plans. We have a standard plan and we have a hedge plan, and I'll tell you exactly what that means in a minute. So this is going to be our main set of treatments, and then we'll have a few more which I'll talk about in a minute. So what is the information that participants get to see? So participants get to see this figure basically. So sorry, they get to see this figure, but this is a figure that mirrors exactly what a real retailer has on their website. Okay, so the information that we provide them pretty much mirrors what is being provided in these real markets. Okay, and also this is also what all the participants see. So this is from the retailer's website, and this is what our participants see, and this is basically the frequency of wholesale price bands. So basically they are told that with 0.1% probability the prices are going to be in this band, 88% probability the prices are going to be in this band, and so on and so forth. Okay, and that's very similar to what is there in the retailer's website. So these are the 3 pricing options. You have a flat rate option, you have a standard time pricing option, and a hedged real time pricing. So in all of these cases, the consumption, as I mentioned before, is fixed, because I mean, in any case we can't change their consumption, because we are not it's not a field experiment, we're not partnering with the energy provider, right? So, but also this in some sense is convenient, because keeping consumption habits the same is going to mean that we don't have any other confounds in this side, right? So this helps in reducing some of the confounds that you can have in these kind of markets. So that is in some sense an advantage. So in all these pricing plans, and that might be true when you look at your own electricity pricing plans. So if you look at your bills, you have a fixed rate pricing, right? So there is a fixed amount that you get for all of these plans, but then there is also a marginal price, right? So in the flat rate pricing, this is what the fixed amount is, and this is the marginal amount. In the real time pricing, we have the fixed amount, but the marginal price now depends on the wholesale market. Okay, so that is what is going to change, and that is what they have to choose. So they don't know their total bill, so there is an uncertainty. So that is what the risk is, and that's what we are trying to understand, whether subjects understand this risk or not. And the marginal prices in the experiment are going to be selected from a distribution of wholesale prices which are constructed based on real prices. So here you can see that the fixed price is a bit higher for a hedge plan, and this is because this is the premium that subjects have to pay so that they don't face as much risk as they would in this plan. So why don't they face much risk here? This is because there is a cap. The marginal price is capped at 28 cents. So the marginal price can't go above 28 cents, whereas in this one, marginal price can be anything. Okay, so that is a tail risk that we are talking about. But here you can hedge against the tail risk, against the really high extreme price risk. But for that you have to pay a premium in terms of fixed price. Okay. So this is what the participants see if they are in the standard information treatment. So they see that there are 3 options. You have this flat rate price, you have a real time price plan 1 and plan 2. If you choose the flat rate plan, you're going to be charged this 22 cents and there's going to be a fixed price. Okay? And with the real-time plan, if you choose this plan, you're going to be charged a time varying price. You can't mention a price here because we don't know what the price is going to be. That's going to depend on the draw. And here you have also a fixed price. And in the second plan, second RTP plan, there is again a time varying price, but now there is a cap at 28 cents and there is a fixed price. This is what they see for the standard information. In the detailed information, in addition to what I just showed you, they also see what their bill would look like. Okay, so in this case, their bill 100% of the chance, 100% of the time, their bill is going to be fixed at 300. Whereas here, their bill is going to vary from 201 to about 441. Okay, so that is what the difference is with the real-time pricing plan. Of course, the percentage of times that the frequency that it is going to be really high is small, but it can happen, right? That's the tail risk that we are talking about. And in this case, because there is a hedge and there is a cap, what that means is that prices can't go above 371. Okay? So that's what they see with the detailed information. Now the question is, how does this detailed information as compared to the standard information, how does that affect their choice between these plans? And that's what I'm going to show you. Before that, so before I show you the results for that, I'll also mention some of the other treatments we run. And this is to basically tease out what is happening in this main treatment. So we also have some treatments where we have pairwise product offerings. So in the one that I just showed you, there were three options, but maybe there are multiple things going on there. So we wanted to also have treatments where you just have 2 options. So we conduct these 4 other treatments. And overall we have 6 treatments in the paper. So we have, this one is, T1 is where they have to choose between a flat rate and just one of the plans, RTP1, and here it is flat rate versus RTP2. And this is the one I just showed you in detail, with all the information, right? So this is where all 3 plans are being shown to the participants. Okay, and in all of them, we have the same procedure, so all of the other details are the same. Okay, so let us now look at some results. Yes. So now what happens when you provide more information? What we find increases RTP choices across all rounds. So you can see that the one in dark blue, that is the control, and the one in light blue is the treatment. So with the treatment, what is happening is that the fixed rate, the fixed plan choices now are going down. And this is going up a little bit, but most of the increase is in this hedged treatment, right? Overall though, what we find is that the propensity to choose RTP is greater than the propensity to choose the fixed rate plan, right? So fixed rate is very small as compared to the RTP in total, right? So most people seem to like the RTP, the real-time pricing plan. What does information do? Information makes them go more towards the real-time plan as compared to the fixed rate plan. Okay? So let's now look at the other treatments where people just have 2 choices. And what that seems to show is that information has a bigger effect in increasing these hedged RTP choices. So this is driving the increase in the RTP choices, right? So here there is a bit of a difference, but not much. So this falls down and this goes up a little bit, but here this is a big difference, right? So it could be because of the price savings, it could be because of the risk perception, and we are going to now tease out from the rest of the data what is happening there. Okay, so this is what I just showed you. This is basically your control and the treatment. And what we are finding is the same result that I just showed you before, that flat rate choices are lower when you provide more information. And you can see that by just looking at the magnitudes, so here this is much lower, the treatment arm is much lower as compared to the other ones. Okay, now let's look at what happens when people get to see a price from the previous period. So what is the impact of exposure? So that's this red bit here. The first one is what I showed you before. So now we are looking at the different rounds, and what you find is that when you observe a high marginal price, this decreases the choice to take up an RTP plan. Okay, so once you're burned, basically you have a lower probability to take up this RTP plan. So then in the the next couple of slides, I'll talk more about the mechanism, but maybe I can just show you a table. So what we have is we have data on risk perception. So we ask our respondents what are the chances of a customer or a real-time pricing plan receiving an unusually expensive bill as a result of high wholesale prices, right? And we see what is the response to this particular question depending on which treatment you are in. So whether you're in the standard information treatment or the detailed information treatment, and also depending on your exposure to high or low prices. Okay, so when we do that, we find that the information treatment doesn't seem to help much, and that is in some sense an explanation for our first result, because we find that when you provide information, people seem to be going more towards a risky product, right? And this is because the risk comprehension doesn't seem to be very high for that particular treatment comparison. However, exposure does have a big impact, and exposure does mean that people they go away from this RTP plan. So I have a table, I think, if I remember correctly. Yeah, so we have a table here. So this is basically the question that I just mentioned and the different options that people have for this question. And this is the information treatment, and you can see that this is, there are very few, there's just one which is a bit significant at the 10% level here. So information does not affect risk comprehension or perceptions, right? And that gives you some explanation for the information result. However, when you look at, so this is the variable for exposure, and what you find here is that this is very significant, right? And this basically helps explain the fact that people move away from the risky product. Okay? So I just want to circle back to the conceptual framework that we talked about before, and what were the different mechanisms that we identified there. So we said that there are these four scenarios that people can find themselves, in. You can be in this one, and the two that were interesting were this, number 2 and 3. And what we are finding is that for the respondents who are switching away from the risky product, the experience of high prices makes them more aware of the risk. So it is the perceived risk being higher, which is the mechanism that is acting here. Okay? And so this is the experience effect which dominates for these respondents. Whereas for these people here, information is basically conveying the fact that there is some price savings to be had when you move towards the RTP, and this is being driven by this hedged RTP where the risk is being capped because you don't really have very high prices. Okay? Because information can basically provide two effects, right? So there can be the risk effect or the price savings effect, and what this helps us do is to tease out which of this is working in which particular treatment. So I just want to now wrap up. I'm not sure how I'm doing in terms of time. In terms of this project, what we felt was that customers are often unaware of the risks involved with new products, especially in the electricity market. We might be aware of risky products in many other areas, but electricity being an essential service, it is something that can have a huge impact. So if you don't have electricity, even if you're very poor, even if you're very vulnerable, you still need electricity. So it's an essential service. So it's different from many other services or many other commodities where there is also risk involved, right? So the reason why this is interesting and important is because of the fact that electricity is, after all, an essential service. It is important for us to live, right? So when there are risks involved in this and customers are unaware of this, then this can lead to very bad outcomes for society. And there are regulators who may want to do the right thing, who may want to introduce these kinds of consumer protection measures, but often one of the first responses for regulators is, oh, consumers are not informed, what should we do? Let's provide information, right? That's the first response, an easy response, and maybe a valid response, but the fact is that information may not necessarily have the effect that they think it will, right? So this is something to be careful about and think more carefully about these aspects, and maybe because we don't have enough data to test for all of this, these are all new products which are emerging in the market. So it may be useful to run some experiments, or think about what are the theoretical foundations of some of these new mechanisms new pricing mechanisms that are being introduced in the market. And what we find from our data is that experience is actually more impactful than information when you want to convey the risk inherent in these markets. Of course, for some people it's already too late because you already have had such a bad experience, you have lost a lot of money, or you fell ill, or whatever else has happened, because of which this might be already too late. So you need to have, so what are the policies that one can have is something for us to think about. So with the information policies that we had provided, it seems that it doesn't help them understand the risk, but what it does help with, however, is the expected price savings. Okay, so it does serve a purpose. It does, just that it doesn't improve risk perception. But what does help in our situation is this lived experience or the exposure, because this seems to significantly update the risk perception of consumers. So one of the options that are available for regulators is to mandate risk hedging contracts. So if you are to introduce a real-time pricing contract, then maybe one can think of mandating it. So like the Texas regulators, they didn't have a hedge in their market. But that's something to think about and consider how that will make a difference. That does mean that you might have to pay a little higher premium in terms of the fixed price, and some customers may not like that. But that is, obviously a premium that you're paying to reduce your risk further on. There are also some suggestions of having cooling off periods or trial periods. So that is, you can try a real-time pricing plan where the prices fluctuate for your electricity. And you can do this for 6 months or 1 year, but without risk. So that if there is a really high price, then the regulator helps you with it or something like that. So there are some policies being suggested of having a trial period. Of course, some of these policies may mean that when you're exposed to a very high price, and that might mean that you decrease the demand for this product. However, our results seem to show that demand can also be increased via information about price savings, right? So maybe that is where information can help, because if exposure or these trial periods make you think that that's going to decrease the demand for these products, which the real-time pricing products, then maybe you can use information to help boost the demand a little, because the information will indicate how much money you can save if you were to go down with this product. Okay, so now let's see. So why are these kinds of, why is this an interesting issue to look at? If you look at the fuel mix, in most countries, this is just data from Australia, but if you look at most countries, what you're finding now is that renewables are increasing in their share. So if you look at 95 and compare it to 21, you can see that there are a lot more renewables now, right? And they're going up year by year, basically. And this is, I think, true for most countries, which is a good feature. It's a good thing, right? It's good to have more renewables in the market in terms of the fuel mix. Of course, what it does mean is that there can be increased variance in electricity production because we have more renewables now, and that can mean that that prices are also going to vary more. So this is not something that is going to go away. This is a problem that is here to stay. If we want more renewables, then it is possible that we are going to also see more fluctuations in prices. So this is a risk that remains now forever in some sense. It may even grow, and this is something policymakers therefore should not ignore, right? So the main takeaways from the discussion today is that environmental markets can help. They can help align our private and social objectives, and hopefully reduce environmental harm in ways that are cost effective. Because if the costs are very high, then we will see more reluctance in terms of going down this path, so we will see more people trying to avoid these kinds of environmental policies. So if you want more acceptance, we also need to think about costs. We can't only be very idealistic and think about the environmental outcomes, we also need to think about how to get to those environmental outcomes in a cost effective way. So this is an important message, I think. And what we did today was to talk about two projects which have many real world features. These are inspired by real markets that are around us, exist currently, and we need to think about how these markets are designed, because the design can be very critical and it can determine their effectiveness. So there are lots of open questions in these areas, and this I think is an interesting area for research. Environmental issues are becoming more relevant and more interesting to study. And one of the things I didn't talk about at all today is compliance with regulatory policies. I just assumed that all the firms are going to comply and all the consumers are going to do the right thing. But there is this whole literature which looks at compliance with regulatory policies, and I've had the opportunity to work on some of these topics as well, where we have looked at monetary and non-monetary mechanisms. I've also looked at peer effects, how does a social network, how can that be used to improve compliance. But there are many areas within this that are, I think, really quite important, because if people are dishonest, if people have incentives to be selfish or other such things, then these mechanisms are not going to work very well, right? So we are just assuming that everybody will do the right thing, but compliance and monitoring and auditing is a very important aspect of whether these policies work well or not. And trying to design policies which are in some sense deception proof or deceit proof is very useful. So if one can think of these kinds of policies, and I think that's the message for the future generation of researchers, that if you can think of mechanisms which are immune to bad behavior from human beings, because human beings, it's human nature to be in some sense try to cut corners or try to do what is good for yourself and not ignore society. But if we can, as researchers, design mechanisms which are immune to bad behavior of human beings, then we can be very successful in terms of achieving our social goals. So I think that's a very interesting area of research, and I hope some of you would be interested in working on these areas. Thank you.